Hello, everyone. Did you have fun at the conference? Are you excited about all the new Tableau features? Yay! Yes, we are excited too. Before I get into the topic, I want to do a quick poll. How many of you have used our performance recording to analyze your slow workbooks? Say about 25%. The topic for today is to go over some of the tools and techniques that you could use to understand your performance or workbook performance. We are going to go over some of the Tableau queries that we generate, when and why we generate them. Let me introduce myself. I'm Pritham Pamu, and here is my partner Lingyan. We are part of the query team. The query team is mainly focused on improving query performance and query functionality. Throughout this presentation, we have some tips on what all to look out for when you're dealing with slow workbooks. We are going to start out with a brief overview about the query ecosystem. We are going to go through the Tableau desktop and the Tableau server environments and go over where all we do query processing. And then we are going to do a brief primer on performance, what to look out for. And we are going to take a few of the scenarios. We are going to start with some basic ones and go over some of the complex scenarios. And towards the end, we are going to go over the most common query optimizations that we do, and then cover the query logging that is there in the product. We are going to have Q&A at the end. So this is a typical Tableau desktop. When you're interacting with the Tableau desktop, it runs queries against your backend database, or in case of extracts, it runs against the Hyper database. So when you open a workbook, let's say, depending upon the dimensions and the measures that you have part of the visualization, we do some pre-processing and figure out what is the data that you need to query from your database. So that's where the query compilation comes. We generate the SQL that needs to be run against the database. If you take a Tableau server scenario, it's the same processing that happens, but in different processes. So in the case of a Tableau server, you open a browser, you open your dashboard. So even here, it does the same processing. But if it is an embedded workbook, we do it as part of this process called vSQL server. But let's say you have published a data source. In that case, there's more processing that happens. That's part of a data server process. So depending on where the query processing happens, your logs are pretty much, they're spread across different processes. And if you have an extract where you are doing extract refreshes, then there is query processing happening on your backgrounder process. But it's the same processing that's happening over the different processes, and some of the tools that we are going to show, they are going to help with this. The motto of query processing is to generate fewer and simpler queries. Fewer queries, so you could have fewer round trips to your remote database, and simpler queries, so we could cache them and we could leverage your cache. Now, Lingyan is going to give you a brief overview of performance and how to measure it.
Let's talk about performance now. As Pamu mentioned, we both work in query team. Over the last couple of years, we've seen some workbooks that are awesome and performant. However, we've also seen some other workbooks that really struggle with performance. In this section, we hope to give you some tips to help you achieve better performance in your workbooks. The first and most important thing for performance is that we always need to measure. Measurement and performance always comes hand in hand. To measure performance, we need measurement tools. Ideally, they should be easy to use, be precise, keep you in the flow of analysis, and not affect the performance. Let's talk about an example now. I'm going to use a viz from Tableau Public to show you a short demo for investigating the performance issues. This is a dashboard. It shows different fasting periods for different countries all over the world for Ramadan. The fasting period is defined from dawn until sunset. So depending where you live, you may have different experiences. The view in the above, it shows a map of different countries. So it has different colors. The darker color indicates longer fasting period. The view below, it shows multiple semicircles, each of them indicating fasting period for a country. The good thing for this dashboard is that we can explore that. Let me hover my mouse over Russia, for example. You will see the corresponding semicircle is highlighted below. Look at how fast it is. Let me do it again. For example, China. So it's very fast. The corresponding semicircle is highlighted below. However, if I do the same actions in the opposite way, for example, I hover my mouse over Iceland, so you will see there are some delay for the highlighted area to be shown in the above. Let me do it again for Algeria in Africa. So there are always like 2 or 3 seconds delay for the highlighted area to be shown. We will see there are something strange happening in the map. So now let me go to this map view to see what's going on there. So this is the map. We just saw it. Where do we start? So let's look at what's in this map. It has rows and 1 row, 1 column here. And also in the marks, it has several fields. And we may wonder, how many marks and the rows columns in this map? Let's go to look at the bottom left corner of Tableau. Let me make it large. So you will see there are over 20,000 marks shown in the map. That should be a red flag, right? So let's go back. Let's look at one country, for example, Australia. Let's see what's happening there. It has 323 Australias shown in the map. This is not right. We only have one country, one Australia. So the problem is that we don't have enough aggregation on this map. So we will see there are multiple fields here. Which one has these duplicated marks? We need to try them one by one. In this case, it's actually 2 fields, dawn and sunset. They are duplicated. So we need to add some aggregation on that. Let's click dawn and go to measure. So they are all duplicated values. So it doesn't matter whether I choose mean or max. I only need one value. So let me choose the minimum. And I will do the same thing for sunset. Similarly, I will choose minimum. Now let's go to look at the same corner again. It has only 48 marks. That's more reasonable, right? Now let's go back to the dashboard to see if we fix our problems. Let me do the same actions again. So this is Iceland. You will see how fast it is. It's shown it's highlighted in the map. And let me do it again for Algeria. It's very fast. So we fix our issues. So in this example, together we find and fix a performance issue. In general, we may wonder, when do we see performance issues? So the most common parameter is data size. It depends on how much data in your viz and also how much data in your data source. So it's data in or out. Our demo falls into this category. And also we've seen some data source. It has a lot of columns and rows, maybe hundreds of them. That could be another important factor. Another most common parameter is complexity. Suppose you have a workbook. It has a lot of worksheets and many quick filters, and also long and nested calculations. That could increase complexity dramatically. Suppose you have a workbook. It has large data size and high complexity. You will see this annoying waiting icon there. That's exactly when you see performance issues. In the next section, I will talk about what's really happening behind the scenes and also different queries being sent to the database for different scenarios. In addition, I will also talk about several tools that could be very useful for you to investigate performance issues. The first tool I want to talk about is performance recording. So for desktop, we can use performance recording. And for this, I will do a short demo for it. Before I open any workbook, so I will choose a random workbook to do our performance recording. Before I do that, we can go to the help and go to this settings and performance and click this start performance recording. When we click that, it means we start performance recording. And now I can open my workbook. So now it's opening the workbook. It takes several seconds. Then here we go. Now let's go to the same help and the settings and performance. Click this stop performance recording. So now it will automatically open a workbook which shows the performance recording results. This is a dashboard. It has 3 views. The first view is called timeline, and then events, and then query. So for example, we look at the timeline, we will see there are a lot of events happening there. If we only focus on performance issues, we can only focus on events which takes longer time. So a good thing here is we have a filter here. So it allows us to show events taking at least, for example, let me type in 0.5 seconds. That's half seconds. If I click enter, there is only a few events left there. So it means all these events, they take at least half seconds. If we are interested in the query events, we can go to look at this executing query. If we click that, then the query will show below. You will see how the query looks like. And now let's go to look at this timeline and events view one by one. This is a timeline view. There are several columns here. The first 3 columns, workbook, dashboard, and also worksheet. They identify the context of the event. And the event column, it identifies the nature of the event. Then this last column, it shows the elapsed time for each event. We are still interested into query event. So now let's look at this executing query. For example, suppose we think there is one query. It takes a long time. It shouldn't be like that. We can go to look at where this query generates. So for example, this one, we can go to this column dashboard and also worksheet. We will see it's actually dashboard art and worksheet course issues this query. Then we can go to that specific worksheet to see more details. The other view is events. So it shows all the events. It's sorted by the duration from the largest to the least. If we only focus on performance issues, we can only focus on the longer events here. So we will look at those events to see any events taking more time than it is. So this is the performance recording for desktop. If we want to go to see more details, we can go to this link. We can also do performance recording for server. For server, there are 2 steps. The first step, we need to enable the site settings. We need to go to the settings and enable this recording workbook performance metrics. So for this, we may need some permission to do that. We can also ask the site administrator to help us enable this. The second step is we need to edit the URL for the workbook we want to do performance recording. For example, we have this URL there, and we will add this red string in this specific position. And then we will hit enter. It will start performance recording. You can also see the performance. It will shown in this menu. For more details, we can also go to this documentation, the link there. The second tool is very useful for performance is Tableau log viewer. It allows us to view and monitor Tableau logs. So you can go to the link to download the installers. It's for free. So remember I mentioned I will talk about different queries sent to the database for different scenarios. This is our first and basic scenario, a simple viz. It shows sum of sales by category. So for this, I will also use this viz to show you how could we use Tableau log viewer. Let me close this. So I will use this very popular and classic data source, Superstar. And now I will open Tableau log viewer. It's very useful to place Tableau log viewer and Tableau desktop side by side. Now I'm going to make it. So before I do anything else, I will first refresh the data source to invalidate all the caches. And now, one important feature for Tableau log viewer is that you can go to this live capture and click this open log.txt. It will directly open the log where it is. So let me do it. We will see there are already some events here. So each event is identified by time and the key of the event. Now, another feature for Tableau log viewer is this highlight. If you go to this highlight and click, it will open a dialog. If we are only interested into query event, we can type in the event key here. For example, end protocol query. And then if we click OK, all these events will be highlighted using this yellow color. Let me click OK. You will see all these events are highlighted. And another feature is that it allows us to show only highlighted events. if I click this highlight only mode. So now we have only these highlighted events here. And also we can click this clear events to start fresh. Let me click that. And now I will finish my viz. I will drag sales and category. So it shows the sum of sales by category. Now let's go to look at the query events. If we look at the last one, we will see this is the end product query event for rendering this viz. The query in the middle is the SQL statement. We will talk about this event in more detail. I may close it. Now let's disable this highlighted only mode. There are also many other features that are very useful for Tableau log viewer. For example, if we go to this menu here, right-click, then we will see there are other columns there that can be useful. For example, I want to show the severity for each event. If I click that, it will be shown here. And also, if we are interested into this specific event, what's the time difference between this event and other events, we can right-click that and show time deltas to this event. If I click that, then this event will become 0, and other events will be the time delta to this event. So this is our simple viz. These are the features for Tableau log viewer. And also we have some useful query events that we can use for investigating the query. The second scenario is we will add a filter to this simple viz. For example, I will add a category to the filter to only show furniture and technology here. What the query looks like for this viz with a filter. Now let's look at this. This is the same end protocol query event. In the middle, it shows the SQL query. And also it shows the number of rows and columns this query returned. It shows the runtime. For example, this query takes 2 milliseconds to finish. And also the connection the query is running against, in this case, is hyper. And also query category is data. The query category shows the purpose of the query. This query is to get the data. Let's look at the SQL. So the first line is the category dimension. The second line is our measures, sum of sales. And also this whole where clause is the filter. We will also see this furniture and the technology is inlined there. The third scenario is large filters. We've seen for the small filters, we just inline this whole where clause into our SQL statement. However, for large filters, what do? We will generate a temporary table for it instead of placing all these elements into our SQL statement. Let's look at the example. So in this example, I want to select 757 customers from this customer name column. So this is a very large filter, right? So what do? First, we will generate a query. It has this query category temp table. And also this long name is the name for the temporary table. This query is to create a temporary table. And then we will populate this temporary table by inserting these 757 values into this temporary table. At the end, we will use this temporary table in this data query to get the data. This temporary table will behave like the filter. One important thing to keep in mind is that if we have performance issues with large filters, we should not only focus on the final query, because sometimes it might be the queries which create or populate the temporary table that has issues. The fourth scenario is quick filters. So for quick filters, we will generate extra queries to get different values displayed in the UI. It has an option called only relevant values. It can be useful when you think there are multiple quick filters and then they can affect with each other. So try avoid this, because they will generate queries which are more complex and have joins in it. Let's look at this simple viz with quick filters to look at how many queries it generates. So there is no surprise. For the main viz, we will generate a query to render that. And also, for each quick filter, we will generate one query for it. So finally, we will generate at least 4 queries to render this simple viz. The last scenario is multi-connection data source. It's also called data integration or data federation, which is to combine data from multiple data sources. The federation engine is Hyper. So this example shows we try to get data from different places. You can distinguish different connections by different colors. So in this case, we are combining sales from SQL Server and customer data from Oracle. Let's look at an example. So in this example, we try to get sales data from SQL Server and the customer data from Oracle. We want to combine it, and suppose we also add a filter on customer. This is a query that looks like in our mind. However, the problem with this query is that we cannot execute it in this way. Behind the scenes, Tableau is thinking of a query more or less like this. First, we try to get sales data from SQL Server and move it into Hyper by generating a temporary table. And then, similarly, we will get customer data from Oracle. However, in this case, Tableau is clever enough to figure out there is a filter applied to customer. So it will apply the filter first and then move the data into Hyper by generating another temporary table. So now we have all the data in Hyper. Then we can combine them by generating another query to combine the data and to get the final data for our viz. So how many queries it generates? Of course, there is one query in context of SQL Server to get the sales data. And also, similarly, another query generated in the context of Oracle to get customer data. And then in Hyper, we will generate 3 queries. 2 of them are for creating temp tables, and then the final query to combine the data. So the next section is all about calculations. First, I will talk an example using the tweets from India's Prime Minister. We will analyze his tweets to find all the hashtags in his tweets. So this comes from a viz from Tableau Public. Before we dive into the calculations, let's look at what is the original query. This is our original query. See, it's very complicated and very long. It doesn't fit in the slide. For your information, I will put a sample tweet here. In this tweet, I will find hashtag yoga day. That's our target. So we will generate two calculations. We will write down two calculations. The first calculation, we try to find where is the hashtag symbol. We call it hashtag part 1. And then in the second calculation, we will use this first calculation for 5 times. And as you can see, these two calculations, they are pretty long and complicated. It also has if, else, and also different functions involved. It looks very complicated. What is the alternative? We can use regular expression to do this. First, we need to find the hashtag. And then this hashtag is followed by one or more word characters. \W indicates any alphanumeric character, and plus means one or more of them. And finally, we can capture it using this parentheses. So it's done. It's pretty simple. No ifs, no nested calculations, and no different functions involved. For those of you who don't use regular expression often, don't get intimidated by it. It's not unique to Tableau. You can get plenty of help online. For example, you can go to this register.com to build your regular expression there. The good thing for this website is that you can copy-paste your sample data there and build your regular expression interactively. And when you are done, you can copy-paste your regular expression to the Tableau desktop. Another tip for long and nested calculations is that when you use an extract, you can try to optimize it. You can click this extract and go to compute calculations now. If you click this button, it will pre-compute all the calculations and store them in your hyper extract. In this way, there wouldn't be multiple queries generated again and again to compute those calculations. So for this, I will give the control back to my partner Pamu for the rest of the presentation.
Thank you, Lingyan. Now we will be looking at a visualization with level of detail calculations. I'll be taking an example on cohort analysis. It's when you want to analyze how groups of entities behave, like groups of customers or groups of individuals. Here, I'm interested in figuring out how customers who we have acquired in a particular year have bought the product over the years. So I'm interested in a visualization like this, where I could see like the customers who bought our product first in 2011, how they have been contributing to our sales, similarly for other years. So here, when you look at this calculation, at this visualization, the complex stuff is trying to figure out what is the year of customer acquisition. So in scenarios like this, you could use the LOD calculation. So this is the calculation. What I want to do is for every customer, I want to find out when is it that they first find the order date. That's what that calculation does. You fix on the customer ID and get the minimum order date. Once you get the customer acquisition date, you could get the customer acquisition year. And once you have that calculation, you could just plot the sum of sales by that. So LOD calculations are really powerful, but whenever you do that, you have to create a subquery, and so that you could do the join for it to, here I'm creating a subquery to find out the customer acquisition date and then doing a join. So when using level of detail calculations, they're awesome, but try to limit the use of those. If you use too many of them, or if you use in a nested calculation scenario, it's just that your end SQL will have too many subqueries. Now we'll be go over a few of the query optimizations that we have in the product. Query caching. Query caching is on by default because query caching always helps. We want to avoid the round trip times to your remote database. Here, when you are looking at a visualization in a browser, there is that refresh now. Whenever you click that, you could avoid all the cache entries and you can run it against the remote database. So anytime you feel that, okay, the data is not fresh, you could refresh it and get up-to-date data. And we have both an in-memory cache and an external cache like Redis. So if you are opening a workbook for the first time, it tries to make use of the external cache. And there are two levels of query caches that we use. I'm going to go over a scenario where I'm going to cover this. Here, this is a typical scenario where, let's say I have 4 queries. I want to run 4 of them. And we first try to look at our abstract query cache. That's the first level of caching. If you are able to get a cache hit, then there's no processing. In that case, it's very fast response times. And in this scenario, let's say the query 2 and query 4 are cache misses. Then we do process them to get the SQL. And even before running the SQL, we again do a cache lookup. And if you are able to get a cache hit, it's good. In this case, I have SQL query 2 where I don't have any cache hit, so I have to run against the remote database. So only for this query, I would incur the penalty of a round trip to the database. And also, you have seen, like, if you are using row-level security, like user-defined functions, in those cases, we try to limit your cache entries only to that user so that there is no data shared across users. And when do we cache? This chart summarizes that. On the x-axis, it shows time taken to run a query. And on the y-axis, I have what is the result set size. So we definitely don't want to cache queries which are very fast, or queries where the result set size is so large that it would just take up a lot of your query cache space. So the sweet spot is to go after the slower queries with smaller result set size. And another aspect that we do as part of query caching is we call it as partial matching. That is, in scenarios where you could infer the result from the existing cache entries, we want to do that. So here I have an example. Let's say I started out, there's nothing in my query cache. I open my first viz, where I am interested in sales for all the cities in United States. So there is no cache entries, so I have to process it. So we run a SQL query for it. And once we get the results, we put it in the query cache. Then the subsequent viz, let's say I'm querying for sales for United States. In this case, I could aggregate the data of all the cities to answer this query. So I don't really need to run a SQL query. So we do that. And let's say after that, I'm interested in only the sales for San Jose City. Here, I could filter the data from my cache entries and answer that. So here we don't run any SQL queries. But in the fourth scenario is where I'm opening a visual where I'm looking at sales for all regions in United States. So here the dimensionality is regions and the country. So I don't have any cache entry matching that. So I would run another query for it. So once I run that query, I would again enter that into the query cache. So whenever you see, when you're looking in the logs, if you see anything like query cache hit, it tells you whether there was a cache hit or not. If there's no cache hit, it will list out the SQL that's executed. And another aspect is the query batching. Like you may have seen a lot of these dashboards where you have multiple sheets in them. So what we do is instead of running all those queries, we try to batch them, try to do analysis on them, and try to figure out what is the minimal set that you need to run? Like you may have to have a batch of 6 queries, but what is the minimal set that you need to run? And then run the rest of the queries using the query cache. And there's something called query fusion. Let's say you are interested in sales for all your cities or costs for all your cities. Instead of running as 2 separate queries, we try to club all the queries that are happening at the same level of detail. Here I've taken an example. This is a typical example from the Superstore sample workbook. Here I have a lot of these sheets as part of the dashboard. So first I'd go over through these sheets and figure out what are all the queries that I need to run. Here I need to run about 6 queries. Instead of running all the 6 queries against the database, we do the analysis and figure out that only 2 queries needs to be run. In this case, they are Q5 and Q6. So I'd run them in parallel against the database. And once that execution is done, we put those results into the cache, and later processing would run against that cache. So that's how you avoid more queries being run against your remote database. The goal of it is to avoid running duplicate queries and to always leverage your cache. Here is one event called query batching event. This is very, very useful. Any workbook that you open, or even a dashboard that you open it in your browser, try to look for this event query batch summary. It has summary of all the query events. If you we are going to go through this slide where we are going to first look at what's the total time taken to run the query batch, how many queries you ran as part of it, and it goes through each one as part of this event. It tells you how much time it took for it to run, what's the source of the query, like what is the dashboard that's triggering it, what's the sheet that is triggering it. And also the query category, like you may be running some queries for data, some queries for populating your quick filters. So there are different categories of queries. And here is the SQL query that I had to run. And we do the same thing for every job in this query batch. So by just looking at this event, you will get a good understanding of what's the overhead of query processing. So, however, the query batching, it doesn't cover all the queries. Let's say you are doing some forecasting or totals where there's some post-processing happens. So we first try to run the batch of queries and do some processing. It doesn't include some of the queries from this, but these are like in some specific scenarios you're hitting that. And when you're looking at queries, try to understand the query categories. The most important ones are the data queries. These are the ones that you run against your fact table. And then when you first time connect to the database, it tries to run some metadata queries, like trying to figure out what are the tables, what are the columns, just to get to know the metadata. And there are a few other queries like figuring out the domain. Let's say I dragged customer onto a filter. Then it has to show you all the list of values. So there are some queries that are run to just show you what are all the possible values. I have a next slide which covers in detail about all these categories with descriptions. So I'm going to skip to that. You could refer to this. And towards the end, I have the query logging. Here for a Tableau desktop, these are the locations where you could find the desktop logs. They differ based on if it's a Windows or Mac. And as for the processes it runs, it's just the Tableau desktop process and Hyper if you're using an extracted workbook. In the case of Tableau server, it's based on the log locations would be under tabs service. And again here, based upon the process that you are really going after, the directory changes. So here, pay attention to the process name, and then based on that, the log file name has a different prefix. And if you are interested in data server, refer to the data server logs. If it's a backgrounder, it's a different location for that. And with this, we'd like to conclude our presentation. I hope we gave a good overview of all the Tableau queries and some of the tools and techniques you could use to understand, to investigate your performance issues. And these are some of the related sessions. When you find time, go through these recordings. And thank you for taking time to attend our presentation. And please spend some time going through this evaluation. It's really helpful for us. And with this, we'd like to take the Q&A. We are going to take it offline, so if you have any questions, please